for a lying between 0 and 360 to the nearest minute. And I'll write the question out now. And the question is, cot of A plus 4 tan A equals 4 cosec A. All right. What's cosec? 1 on sine. Cot. You're going to have to come up with some nice equation. This is really related a lot to identities, isn't it, really? We're going to have to simplify this to some nice equation. I think we should put them all in terms of cos and sine as opposed to tan, because this can't be expressed in tan. This is 1 on sine, sine on cos, cos on sine. Let's try that. And hopefully, or we might end up with a tan somewhere, but let's just see. So we're going to go cos A over sine A plus 4 times sine A over cos A equals 4 over what? Over sine A. Now I can see an equation with denominators. How do I eliminate that denominator? Multiply through by sine 1, not sine squared, just 1 sine A. Sine A cos A. Do you get it? Now, only if you've got an equation do you multiply through. Or if you've got a numerator and a denominator, you can multiply numerator and denominator by the same thing. So I'm going to multiply each term, because it's like I'm multiplying the left-hand side and the right-hand side by the same thing. So if I multiply by sine A cos A, what do I get for the first one? I get cos squared A. And if I multiply the second one by sine A cos A, I get 4 sine squared A. And if I multiply the last one by sine A cos A, I get 4 cos A. All right, it's starting to look like something. I've got cos squared A cos A. Geez, it'd be nice if this was cos. Cos squared A plus sine squared A equals 1. So sine squared A equals 1 minus cos squared A. Whenever you see sine squared A or cos squared A, it's 1 minus the other one. All right, so that's what we're going to... So look, we're thinking, yes, we've got a quadratic. Girls, you can't do cos squared A plus sine squared A is 1. You know why? Because you've got 4 sine squared A's and only 1 of the cos squared A. If that was just a sine squared A, yes, you could have put 1. But it's 4 sine squared A. I would need 4 cos squared A as well to factor out the 4. No, you can't. Because there aren't enough. You need equal numbers of each. You have to do this. It's the only thing you can do. It's if I had 4 cos squared A plus 4 sine squared A, I could say that that equals 4. Because it's 4 bracket. Cos squared A plus sine squared A. Cos squared A plus sine squared A is 1. You cannot add these two together. Cos squared A plus 4 bracket. What do I put here? What do I replace the sine squared A with? 1 minus cos squared A equals 4 cos A. Now I expand. Cos squared A plus 4 minus 4 cos squared A equals 4 cos A. This is looking good. But we'd like a positive quadratic, please. All over to the right. What have I got? This is 1 minus 4. That's negative 3 on this side. So it's 3 cos squared A on the right. What else have I got? Taking it all over to the right. Plus 4 cos A. What else? Minus 4 equals 0. So I have to factorize something that I'm just going to call it y instead of x. Oh, it doesn't matter, x. 3x, x. Factors of 4 are either 4 and 1 or 2 and 2. I think it's 2 and 2. And I think it's plus and minus. So it's 3 cos A minus 2 cos A plus 2. Let's check. 3 cos squared A plus 6 cos A minus 2 cos A minus 4. So therefore we've got 3 cos A minus 2 equals 0, or cos A plus 2 equals 0. In other words, cos A is -2. That has no solution. You know why that's got no solution? Cos must lie between 1 and -1. And cos of A is 2/3. We know what to do now. You should know what to do. Quadrants 1 and 4. That's where it's positive. Positive in quadrants 1 and 4. Cos of A is -2 has no solution because you can only go from -1 and 1 with the cos curve. And we need our acute angle A. And then we have our two solutions. Solution there, A is 48 degrees 11 minutes and 360 minus 48 degrees 11 minutes, which is 48 degrees 11 minutes. Sorry, I forgot my little diagram. Quadrant 1. I'll just put 48 in it, not 4811. All right, or whatever. 360 minus that, 311 degrees, 49 minutes. Okay.